It's second grade addition and subtraction. Believe me, we will handle this. Again, I'm Carol Little. I'm the math coordinator. Today we are going to be working on a lot of the different strategies we use for addition and subtraction. There are a lot of problems in this packet. We are not going to do all of them. I gave you some extra so you can take home and keep practicing, because I'm sure that's what you want to do this afternoon. The big deal that I want to talk to you about the strategies is we are going to do them following a certain order, but they can be broken apart. When we talk about, in math, we call them deriving strategies. We mean you can start doing addition one way and get to a certain point and then go, oh, I can just skip over and use this. Yes, that is what we really, really want. That is a flexible mathematician. But I'm going to teach you the strategies pretty straightforward. I think it'll become obvious when we start doing them that you can say, oh, I could just turn to mental math when I get to this point. Yes, that's what we want you to do, but I do want you to see what these strategies are, so we're going to do them step by step. Again, I'm going to roll quickly because I'm going to introduce them and then we're going to practice them. So I'm not planning on you understanding them the very first time I go through them, okay? First of all, if you'd open your packet and just turn to the page, this is language we use. The add-ins, we use the language with the kids. We do not expect them to, they are not assessed or required to use it, but some kids love it. We talk about using vocabulary a scientist would use, a writer would use. We can use the vocabulary a mathematician would use. Add-in is not so important. The word sum really is, because that is the answer to an addition problem. Not a subtraction, not a multiplication, it only goes to addition. Regrouping is what we would have called borrowing in our younger days, but you know what? When you borrow, you never really get it back, so it's more like stealing. So we're like, let's go to a new word. And especially with manipulatives, we truly regroup. The word makes sense, excuse me, to what we're doing. Commutative property. This again is not. We don't test on that. We would never spell it correctly. Half of the teachers don't spell it correctly. That's not true. I don't. Commutative property they actually learned last year. That it's this idea that 1 plus 2 equals 3, but 2 plus 1 also equals 3. It's this idea that in addition, the add-ins can be flipped around. That's also true in multiplication. The factors can be switched around. It is absolutely not true in subtraction and division. So we've got some parallel things going on, but it is not true for everything. So we talk about it that way. Minuend, subtrahend, and difference. Yeah, I pretty much have to look up minuend and subtrahend every time I use them. They are virtually not used, but it was interesting when I went to write up something on here, it's like how useful the words are when you start describing an equation in subtraction. I doubt that the teachers even use it, but we do use that word difference for the answer for a subtraction problem. Decomposing, we've been decomposing since kindergarten. When we decompose now, it is often by place value, but not always. We are going to do decomposing. Decomposing just means we're taking it apart, so we're getting to numbers that make it easier for us. And so we'll talk about friendly numbers as we go. Okay, the next page, front and back, this is my gift to you. This is the cheat sheet for everything we're going to do today. We need to draw in some things, but this explains what all these names are. Again, we do not test the kids on the names, but they get used to some of them. You know, they are the correct math terms. So this is what it is. This is the really quick way of explaining it. I don't know, as somebody who doesn't know how, I don't know that you could read the 3 bullet points and understand it without being here, but it's pretty close. So partial sums, we take the two numbers, the two atoms, We decompose both of them into their place values. Then we add the tens numbers together, then we add the ones numbers together, and then we add those two together to get the answer. We are now into double digit and heading into 3-digit adding and subtracting. I'm talking about adding right now. So this idea of breaking down by place value is very important. Their entire last unit was on place value. The kids are really good at decomposing this way. This is, I want to say this is probably the simplest or least sophisticated way. It will always work. It's also cumbersome because you end up with all these little things you add and you have to keep adding and you have to keep adding, but it works every time. Partitioning is the same idea, except we usually choose the larger number, we lock it, and we take apart the other number. Because I can add 72 plus 20. Because I know my place values, I'm adding my tens, I get 92, and then I can add on the next 3. It doesn't matter whether that add-in, whether it's the first or second number, it's just wise to lock the larger number. It will work both ways though. So you can see that's just one step a little bit more sophisticated than the first one. Compensation. Maybe I want to do this with one color. Compensation in addition. If we have 4 plus 2, and we put them together, I am going to do it with 2 colors. I've got 4 plus 2, but I can move 1 over, and 3 plus 3 still equals 6. For this problem, that didn't help me at all. But if I had 7 plus, no, I'm going to do that. When I get into larger numbers that I can't add easily, let's do 11 plus 7. If I take 1 away from that 11, I get 10. 10 is about the friendliest number I can get. And I can give it to my 7. I now have 10 plus 8. We are allowed, in addition, to move that break point any place we want. That becomes a very good strategy for certain problems. So if I have 38 and 23, I'm going to take away 2 from the 23. That really should go right there. And then I'll have 21, and this is going to become 40. This picture's not great. There's no way of really drawing a picture of this. I've tried. So now I have 40 plus 21, and that is a very simple problem. It was much easier than 38 plus 23. Okay, we will practice that, but it's a matter of getting to these friendly numbers. They are usually multiples of 10s. They can be multiples if you're American and you've lived in the States. We know our 25s real well due to our quarters. If you grow up with them, those also become easy. A lot of money is broken into 20s, not so much here. In Kuwait we have 20s, and so kids know their 20s quite well. So there are culturally things where numbers are better known than others. Place value chart. This just means that I can break apart these numbers. I can have 100, I can have 30, and 5. Do you see how that represents 135? And then I can add 200, 30, and 1. And now I can count them up. How many ones do I have? 5. How many 10s do I have? I have 6 10s, which is 60. I have 3 100s, which is 300. So I have 365. Thank you.
6 ones.
Twice?
6 ones, yes.
Oh, I didn't, there we go. I didn't write down the, I didn't draw the picture. And therein lies some of the mistakes your kids will make. It's not that I didn't understand what I was doing, but if I don't draw it accurately to begin with, or I don't count out the chips accurately to begin with, you're going to get the wrong answer. Okay, I'm rolling through this because we're going to practice them together. But I want you to have this sheet looking correctly, because this is what you're going to keep holding. Partial differences. If we break apart both numbers, like we did with partial sums, we get in trouble with certain problems. Because we can end up with negative numbers. So here's the truth. We don't do this. But I wanted to show you why. If your child, oh, I do partial sums, I can do partial differences. It works, but your child has to be able to handle negative numbers. 7 and 8-year-olds with good number sets can handle negative numbers up to about -3. It inherently makes sense to them. I still wouldn't push this. If you got a high flyer child who you want to push, I might do one that comes to a -1, but that's that extra extension to get them really thinking. So in general, we do not do partial differences. Adding up to find the difference. Subtraction can be solved by adding. So this is where we've got to pay attention to our language. We can't always say this is a subtraction problem, and that happens more with your word problems. But I can take 83 minus 6. I can use a number line and say, I've got my 76. How many do I need to get to 83? By second grade, we're hoping a lot of kids are going to jump to 80. So I need at least 4. I need 3 more to get to 8. So I need 7. So my answer to 83 minus 76 is 7. And this is called an open number line. I just started with it. I can draw it anywhere. I put my numbers. I didn't quite know, because I was first solving it, how far apart to put my numbers. That's okay. This is not going to be absolutely correct in its spacing. They don't need that by second grade. They can understand, oh, I'm talking about a chunk and I'm talking about a chunk. Often they'll make the first jump way too big and then find they have to make several small ones.
So you recommend to use this one instead of the negatives?
Yeah, this one I just showed it to you because it's a parallel one to this one, and I was showing you why we don't really use it. So adding up, and this is what we'll discover later, there are times when adding up makes more sense than other times. I'm not going to try to surprise you. When numbers are close together, adding up makes a lot of sense. If you got 963 minus 121, that's going to be a lot of jumps. Yeah. And some of these other strategies would be better for it. And so we practice. We talk about this. We talk about efficiency. Which one makes sense for which problem? Partitioning. We have partitioning in addition. We have partitioning in subtraction. This is very important. We have to lock the first number. It has to be the minuend. Then I can decompose the 34 into 30 and 4. 68 minus 30 for a lot of your kids is a mental math problem. Really for most of them, because we understand that this is 6 tens and I can take away 3 tens. I keep track of that 8. And then 38 minus 4 equals 34. Okay, constant difference. Here's our challenging one. We're going to start with really easy or small numbers. If I have 4 take away 2, this is that language again. I'm trying to find out the difference here. Does that make sense? I could do that. What happens if I add 2 more on? Did my difference change at all? What if I add a total, let me see. If I add 5, that doesn't feel like it's going to stay. If I add 5 onto both numbers, did my difference change? It's still a difference of 2. Let me go back to my original problem. 4 minus 2. What if I take away 1 from each? Did my difference change? No, it's still 2. That's the truth about subtraction. If we do the same thing to the first number as we do to the second number, that answer that we're looking for, that difference remains the same. 4 minus 2, that doesn't help us a lot. But when we get into bigger numbers, like 81 minus 37, that's a lot of regrouping. What if I make, and this is important, we're making the subtrahend, and I'm going to explain myself. We talked about this language earlier, ladies. We always look at this number. Can I make 37 an easier number? For most of us, it would probably be 40. So I can add 3. If I add 3 to that number, what do I have to do to the other number? I have to add 3. So now I have 84 minus 40. Is that now a fairly simple subtraction problem? Constant difference is lovely for certain numbers. As we get into the 3-digit numbers, it's not as easy, it's not as efficient. But with 2-digit numbers, it's really, really efficient. And I'm going to tell you, not every child is going to master this. And it's not about being smarter or not as good, it's more how much they can visualize it. And that's why we do it with the cubes first, and that's why we draw it. And then we usually get to, well, you'll see how we do it. We usually write it above the numbers. Not every child's going to master this. Yes?
So, what language would you use for your child? I mean, if I'm sitting with this math problem with my son, would I then say to him, which number could you get to a friendly 10 easier? What would the language be to make him understand what he's looking for?
Friendly, when we say friendly 10, some kids take that so literally that they think they can only go to 10, as opposed to 20 or 30 or 100.
Okay.
So I would say a friendly number. If there's still a blank face, I might suggest what friendly numbers might be.
Okay.
But we don't, the use of 10 is a little dicey. I mean, yes, we use it because that's what we mean, but we don't want them to grab onto that one name. The mathematical term is probably a benchmark number, but if you use that language, you're probably getting further away from their understanding. We're trying to get closer to their understanding. And then the place value chart. Similar to addition, but with subtraction, we only have the first amount. So we have 521. We do not build 231 because we don't have it. That's what's being taken away. So I'm trying to talk to you about the difference between what it looks like for addition and what it looks like for subtraction. So in this case, there was a lot of regrouping. I'm not going to explain it here. I'm going to explain it with the ones that we truly do. So this was your quick view of the cheat sheet. Now we're going to go do it, and a lot of this should fall in place. Okay, we're going to take the same problem and do it the 4 different ways. And we'll start talking about which way was easier for you, there are going to be times when I'm just going to be honest with you, I would never do it that way because it depends on the numbers. How do you learn that? By doing a lot of these problems, and that's what they do in class. You are being brought through at a whirlwind pace. Please be aware the kids are doing it with manipulatives first. They're doing it with lots of practice and a lot of talk first. Okay? So partial sums, if you want to go back and look, that's where we break both numbers apart. So if I have 28 plus 43, this class is all about honesty. Last year, as first graders, they would have done this. You see that up there? No. They would have made it look like a number bond. Unfortunately, mathematically, those symbols mean something completely different. So we're kind of moving them away from that way of writing with it. We're trying to show them the correct way or the mathematical way. We don't even worry about all the notation as long as they are getting the concept right. So for us, we put it in parentheses. Most kids won't. And that's okay. So I broke 28, into 20 plus 8. What would I break or decompose 43 into? Okay, so most kids would write it like that instead of the parentheses. Parentheses just means these go together. Okay, so now, which numbers are like? I'm going to grab my tens numbers, and I'm going to grab my ones. 20 plus 40 is 8 plus 3. Now, some kids may write down 60 plus 11. A lot of kids are going to be able to do that with mental math. That make sense? I want to talk to you about 8 plus 3. Coming into 2nd grade, your kids should have known their math facts to 10. By the end of 2nd grade, they should know their math facts to 20. They should have a fairly known way. If they don't know 8 plus 3, they should be able to do 8 plus 2 plus 1 pretty rapidly. It's not boom, 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 boom stress, but they should have strategies to be figuring these out. And at the end of the day, I'm going to share a math site where they can be practicing these addition facts. But 8 plus 3 by now really should be a known fact. And if not, they've got this strategy of, oh, I can get there real quickly without demanding me to work hard on it. Okay, partitioning. Lock 1, break 1 apart. Which one do you think we should lock?
43.
I would lock 43. And then, after a lot of practice, I'm probably not even going to write that down. I know that's 20 plus 8. So I'm a little bit showing you the progression of what we get to. At first, they're probably going to write that down as 20 plus 8. Now I can just put it into my equation. Extra papers? 63 plus 8. For a lot of kids, that's 3 plus 8 is still 11, but now it's involved in a larger number and they don't all see it. But it's still 63 plus 7 plus 1. And that's a fine way of thinking about it. That's these strategies that we develop to get ourselves, because they do know how to get to tens. Okay? Compensation. Which number would you like to make friendly? Actually, we're going to do it both ways. You want to add 2 to the 28? And this is what I'm saying. This is kind of the easiest way for us to write it. We're back to addition. So I'm going to take 2 from my 43 and give it to my 28. So I now have 30 plus 41. And for me, that's 41, 51, 61, 71. And place value chart. They were doing this last year in 1st grade with this type number. Okay, I do want to talk about how I draw it. This should be labeled tens and ones. It is a place value chart. Whether they write out the words or not, I don't care. Their teacher might for a while to make sure they know what they are. I will always, as a teacher, draw my numbers using, I call them 5 frames. So I got to 5 and then I did 6, 7, 8. Your brain can look at a line of 5 and know it's 5 really easily. If I added those 2 more on there, I guarantee you'd have to stop and count. And then I better have added 3 more on because it's 8. So I do draw them. It's by rows of 5. It's called the 10 frame. If a child is drawing it 8 across and keeps getting it correct, I'm not going to say anything. That doesn't happen all that often. But if a child is drawing 8 across and keeps getting them wrong, I will make them start doing it by 5s. But a child who's doing it a different way but can totally handle it, we leave it there because they are understanding it. But now I'm in the ones place and I have more than 10. I need to regroup them. So I have my 8, take 2 from there, that's a 10. That belongs over here. This is a precursor. This is the beginning step to the traditional algorithm. This is why that term regroup makes so much sense. I am actually making a new group and moving it over to the 10s. So I now have 1, 1. I have 1, 2, 3, 4, 5, 6, 7 10s, which is 70. And luckily, I got 71 4 times for the same problem. So with certain numbers, these are going to look a little bit different, but you can see that I wouldn't say this is more sophisticated than this, but this is going to start working for bigger and bigger numbers, and it leads to the understanding of column addition. We don't do that in 2nd grade. We actually don't get to complete column addition until 4th grade, where we expect it to be easy and we call it the traditional algorithm. They'll be seeing it a little bit in 3rd grade, but really we just practice more with these other strategies because many of these other strategies are actually more efficient than the traditional algorithm, especially this compensation. Okay, let's try it with bigger numbers. So what is partial sums going to look like? 300, I don't have anything to add it to. 40 plus 90, and 5 plus 8. So that equals 300. I go 90 to 100 is 10, 130. 8 and 2 more is 10, and 3 more is 13. And at this point, struggling kids would have broken it down again. They would have added the hundreds together, and then the 30 and the 10 together, and then the 3. Most kids don't need to do that because we're getting to fairly easy numbers here. So this is 300, 430, 443. That makes sense? Partitioning. I'm going to box the 345, and then I'm going to add 90, and I'm going to add 8. Now, I'm going to talk with you. Adding 90. I don't know whether that's so easy or not, but I could add 100 and get 445 and take away 10 and get 435. Kids think that way. So I would be talking out, I mean, I wouldn't write all that down, but I would definitely be talking that way. We've done that sort of strategy with 1s. We can do that with 10s, and we can do it in the middle of big numbers. Yes, I'm now talking about the kids who have good number sense, but we all talk about it. So I now know this is 435. And as we start doing this, there are kids that will want to check off what they've done. Great strategy. Staying organized is part of math. So now I have 435 plus 8. My thinking is, well, 435 plus 5 is 440, plus 3 more is 443. For some kids, they might need to see that like that.
Excuse me. So what if the student added the 90 to the 8 and then took away the 2? Wouldn't that be easier? So 90 plus 8 gives you, instead of the 98, you round it off to 100.
Okay,
That's-
which is,
Oh,
and what you're now doing is combining two parts. Absolutely. I really would hope, and we're going to talk about why it becomes 100 in compensation, but yours is a little bit different. In compensation, we take and give.
yeah.
Yours is we can add 100 and then just take 2 more away, because I added 2 too many, made it easy for me, and it's really easy to take 2 away. If a child said that in my class, I would stop teaching for the day and bring that child forward and say, you just keep going, kid, because that's the flexibility in math that we're really looking for. Not this, oh, the teacher said I have to do this first, and then this second, and then this third. And we don't have names for all these strategies. I mean, they start being parts of this and parts of that. So compensation, okay, I can get that to 100, that would make my day. That means I have to take away 2 from here. 343 plus 100 equals 443. I'm trying to, I want to remind myself to talk, when we get to the very end, I'm going to show you this arrow notation, which would show what she said beautifully. Okay, place value chart. Do you get the place value chart? Let's do it. Hundreds, tens, and ones. 90. 5, 1, 2, 3, 4, that's 9 tens and 8 ones. So we are now regrouping twice, which used to be the day teachers wanted to call in sick, because we were telling them in the standard algorithm, oh, you just take this and you put it over here, but you have to add 10, and all these ways that kids didn't understand. And excuse me, I put these on your desk and I'm very aware of time. We build these first. You can look at them. We would have built this and made them, it would have been 3 100s, and then no more hundreds, and then 4 10s. We would have done this with manipulatives first. We don't, I'm sorry to say, I want to, this is too much important stuff. So we go from the building it and then drawing it at the same time, and then slowly we don't need to build it anymore. So now I've got some 10s here. That 10 ones needs to go over here. That leaves me with 3 ones. Well, here's another 10. 10 10s goes over here. I have 4 10s, which is 40, and I now have 4 100s, which is 400. And I get my 443. Your kids are being introduced to these one at a time. I wanted you to see how each one of these affects a problem. Your children are going to pick favorites, and when we are teaching partial sums, we are going to make everybody do partial sums for a day or 2, or 3 or 4. Because if they don't practice it, they'll never know whether they really like it and want to replace it. Same thing when we get to partitioning. We're going to have some kids who go, but I like partial sums better. And we're going to say, that's fine, but this is like a sport. Today you need to practice this. Because until they get comfortable with this, they're not going to like it. In soccer, you better be able to shoot a goal with your right foot and your left foot. For most of us, that left foot is awkward until we practice it and practice it and practice it. And this is the same thing. Then we're going to go to compensation. And what they're going to discover with doing all these is there are some problems that these just don't work as well for. Such as 384 plus 427. Can we agree that we know how to break it apart and put it together? We know how the partitioning works. I want you to think about compensation. Can I make either of these 2 numbers easy? And when I mean easy, to the hundreds place now. Because for me, let me write this down. If I were to get 427 to 420, it kind of almost doesn't help me much. This is kind of what I would call an ugly problem. It's not harder, it's just not very simple. So if I did plus 3 minus 3, I have 381 plus 430. And for most of us, I still have a lot of work to do. So I purposely gave you one. This is not one that I would ever choose compensation for. Compensation works really well when you're near a friendly number. Like 104, yes, I can get rid of the 4. 692, I can grab 8. When they get into the middle area, this is where we start talking about, this is why compensation doesn't work for everything, especially as we get into larger numbers. So, I wouldn't use compensation for this. Am I gonna let a child try it? Sure, go for it. And that's the challenge, and that child just needs to prove it for themselves. That's great. And the place value chart works wonderfully for this. So I'm going to leave you with those. We're not going to walk all the way through them. I think you've got a good understanding of the 4 strategies, and you understand that once I know them, I can start mishmashing them around. Okay, subtraction. So I flat out told you, when the numbers are close together, adding up makes sense. So I have 86 minus 52. Are those close? That's a judgment call on the child's part. So I have 52. I need to get to 86. Well, I can get to 62. I can get to 72. I can get to 82. And I can get to 86. So my answer is 34. Or 52, I can jump all the way to 82. That was plus 30. And I can add the last 4. I get the same answer. How they lead is going to depend on their comfort level and their number sense flexibility.
Can I ask? Probably it's not related, but why do you put arrow in both sides?
It just mathematically it means the number line, I'm jumping into the middle of it. On a number line there's no beginning and no end. So it goes down to 0 that way and it goes up to infinity that way. It's just what you do in math. It's just to let you know that we're using a number line. If a child didn't put the arrows, I wouldn't care. That's really rote habit for me. Okay, that makes sense? Partitioning, 86. You've got to lock it, but can I take away 50? Absolutely, I get 36. 36 minus 2 equals 34. I am obviously comfortable with this. Many kids might have had to do 52 is 50 and 2. You can't see that. Okay. This is where a lot of the kids are comfortable. It's a perfectly good way of solving a problem. Okay, I draw this. I have 86. I'm taking away 52. And I want to know this difference. I have to get the second number to be friendly. That's a part of this. Okay, so I'm going to take away 2 from each of these. So I now have 84 minus 50. And for a lot of kids, that now becomes mental math. And I would probably write in not negative 2, minus 2. I do the same thing to the top and the bottom. I didn't really know about constant difference until about 5 years ago. It's like, who has been keeping this secret from me? It can get you to get away from a lot of the regrouping, which is where most of the errors are made. And place value chart. the important thing about the place value chart and subtraction is you only have the first number. And if it's put in a word problem form, it actually makes more sense. I have 86 apples and I'm taking away 52. It makes sense that I can only draw the 86. And now I'm going to take away 52. Okay, take away, just mark them off. I don't care where you do it, from the top or the bottom. What I'm going to look for is, can you do it accurately? If you're not doing it accurately and you're doing it helter-skelter, I may try to have you find a pattern, because our brains like patterns. So what do I have left? I have 4 ones, I have 3 10s, I have 34. So when we talk about kids checking their work, when they have multiple strategies here, they can go back, solve their problem a second strategy, and if they get the same answer twice, it's probably right. I can guarantee you kids can make the same mistake twice, but that's rare. And if they get 2 different answers, that should tell them you better go back and look at something because something's wrong. Okay, adding up 172 to 56. Here's kind of where you're going to start seeing these numbers aren't very close together. I'm going to do a lot of hops. I don't know how much it's going to help me. So I'm going to go 66, 76, 86, 96, and at some point I'm going to go, this is a silly way of doing this. But I got to 96. I'm going to go plus 4 and get to 100. Now I can jump 72. Have I helped myself much? Yeah, a little. It's 72, 82, 92, 102, 112, 116. And when we do a lot of these in a row, they're finally going to say, I don't want to do that one anymore. And we're going to talk about why did you not like it here and you liked it here. And we're going to devise that understanding of, these numbers were too far apart. So I'm going to kind of put an X through this just to help you remember that's not working real well. 172, subtract 50. This could be stretching it for some kids. I can do it. I would say half the class is going to be able to do it, but half the class isn't. So we get 122, and then I have to take away that final 6, and I get 116. This is going to keep working well for kids with strong number sense.
If some kids get confused from the 122 minus 6, for example, it's okay if they do a parenthesis, right?
Yes. So they could, they get here and they go, that doesn't help me. They should, well this, I should do parentheses. This should be 2 plus 4. Now I can take away 2, I get 120, and 120 minus 4 equals 116. Absolutely. That, again, that is the flexibility we want to start hearing. I get it. I get to a certain point, now I know where I'm at, I know where I'm stuck, and I know how to get myself unstuck. As opposed to memorizing how to do something and you get stuck and you've forgotten what you memorized, and then you can't help yourself. 172 minus 56. Can we make this number more friendly? I would say you could add 4 to it. Oops, my picture's not going to be great. If I add 4, I now have 176 minus 60. For a lot of kids, that's going to be a reasonable problem. But for a lot of kids, This last one is where they're going to go. This is not particularly a very pretty problem. It's verging on ugly. And the place value chart will always work. 100, 72, except those are hundreds and those are tens. I need to take away 56. Can I take away 6 right now? Except that last unit I learned I can take any 10 apart I want and get 10 ones. So I'm going to take away, and I'm going to put my 10 ones over here. So I'm now regrouping the other direction. I'm taking apart a 10. Now can I take away 6? Absolutely. And then I'm supposed to take away 50. Can I take away 50? Ooh, thank goodness I can. And then that's all I have to do. So what do I have left? I have 4 ones and 2 ones. I have 6 ones. I have 1 10 and 1 100. And I get 116. This way with the regrouping is where the kids that are struggling more with number sense, this will always work. And we do practice enough with the manipulatives that the regrouping really does. What will become is this is going to become an organizational issue and a handwriting issue. Fine motor skills. We love our screens, we love our iPhones. Our kids' fine motor skills have gone way down. They are not able to write real small. They get tired writing because all they're doing is using their thumbs or swiping. So the problem here won't be the math, it will be the organization and the writing. If that's a problem, I'm not going to beat up a kid over that. I'm going to get a larger piece of paper and I'm going to let them draw a number chart that big. We want the accuracy. Making it super small is not the point. But it's going to show me that I should be having my child write more. I should be having them color with crayons, not markers. Crayons, strangely enough, have that little bit of a drag that it works. It's more, you build more muscles with crayons than you do with markers. Chalk is another good thing. Cutting, please. Let your kids cut at home. Origami, folding a paper. All those things use their hands and build up the strength, which makes it easier to do fine details. Okay. I'm trying to think if we ran across all the instances, because I want to get to this part. So I gave you 2 more problems. If I made you work them all out, you'd find that some work better, some you're going to like better. But I'm going to leave that for you to do. I will put the answers up on Taneen by the end of the week, so you can check your work. I want to get to Arrowway is a name that you may hear your kids use, and it's about how we write things down. It's very, very related to the number line, but it's also cuts down on us having to write a whole bunch of equations. So all it is, as it sounds, you write an arrow and you say what you're doing above it. So 39 plus 1 equals 40. 56 plus 10, 66. 42 minus 10. So we can go either direction. We can go up and down, and we can combine addition and subtraction into the same problem. So back here, what was that lovely problem? It had a 98. 345.
Could you move your paper a little bit?
Yes, thank you. This is a new screen, and I'm just not used to it. So we saw 345 plus 98 on the other page. I could do 345 plus 100 is 445, but I added 2 too many, so now I have to take them away, and I got 443. I call it stream of consciousness. It's actually what I'm saying in my head that I do. But if we were just to put equal signs in there, it would be wrong. So this is just a way of writing things down. It's the same strategies that we were using before, but it's a different way of writing them. So I'm going to do one more. I'm going to do 243 plus 521. I'm going to add the 500. So I'm partitioning. I'm keeping my first number locked. I'm adding the hundreds. I have 743. I'm going to add my 20, 763, and I'm going to add my 1 and get 764. And I'm not asking you or the kids to know the difference between a strategy and notation, but I used the partitioning from here. I just wrote it down. This makes a lot of sense to the kids. On a number line, when you add, you always go to the right. When you take away, you always move to the left. This, it's just, no, I'm writing it down. I'm keeping track of what I'm doing. I'm adding, I'm subtracting. And I can do anything I want with it. So, let's do 65. Okay, I am going to take away 45 because I know that gets me 20. So in this case, I did not break it apart by place value. I got 20, and now I have to take away 3 more to get 17. I'm going to say virtually unlikely that a second grader would ever do that.
Yes.
But that shows you what you can do. Okay? I say that. I'll bet you there's 5 kids in second grade that can do that easily.
Yeah, that was my question.
But what I did was I immediately saw the 65 take away 45 gets me to a friendly number. That was easy for me. That would be high level. But we've got kids in second grade. We also just want to give the kids the opportunity that they get to make the choice. Okay, I want to get to modeling, which is one of the biggest questions parents have. Modeling at our school is about, we have a problem, it's written in word form, it's real life. What is the actual question being asked? How can I make a visual representation of the question? We can then use that model to help us solve it. Sometimes it's within the model, sometimes it's separate numbers elsewhere. Okay, 39 books were on the top bookshelf. Marcy added 48 more books to the top shelf. How many books are on the top bookshelf now? So what are we expecting? I know there are 39 books. I know there are 48 more books. I do not know the total. And I'm going to show you, this is being drawn 2 different ways. I just really, I don't want to make a rule saying you have to do it one way or the other. They mean the same thing. We do want question marks. Question mark is what we're trying to figure out. This is the visual representation, but it needs labels. Oh, I've got the wrong number down here, 39. Okay, these were books. These were more books. And then that's the total. Tomorrow, I could walk in here. This is called a tape diagram. Could I walk in here tomorrow and know what's going on? I could say, oh yes, there were 39 books and 48 more books, and I need to find the total. That model represents the question that I'm doing. I'm not going to worry about solving it. We just did all that other arithmetic. Okay, so what if there are 53 regular pencils and some colored pencils in the bin? What do I know? I know there are 53, and I know there are some. Do I have the answer? No. There are a total of 91. These are regular pencils. These are colored pencils. And those are the total pencils. can I now look at this and figure out what I need to do? I could add up, or I could subtract to find that answer. But I now have a visual representation of the math I need to do. On this one, most of the kids are going to do the work over here. Matthew has 68 stickers. John, his brother, has 29. How many do they have all together? Okay, I know how to do that. 68, 29, and all together is my question. This is Matthew, and this is brother. I'm going to be very honest. Some teachers are going to make them write out the words. Some are going to say abbreviations are fine. Some are going to have them start writing out the words, but let them get to abbreviations when we know they know what they're doing. By 5th grade, believe me, we're into single letters and stuff. But when we begin, we often need to do it the complete way. This should be labeled stickers someplace. That's what the story's about. Now, how many more stickers does John need to have as many as Matthew? This just became a comparison problem. Matthew has 68, his brother has 29. We need to find this difference. So my picture looks a little bit different. But when I can see it that way, I now know how to start figuring it out. Okay, I'm at 1 after. Can we hold on till 5 after? I just want to give you, these are all each a little bit different. Frederick counted a total of 80 flowers. There were 49 white flowers and the rest were pink. What do I know? Do I know the total?
Yeah.
Okay, I can put the total down. What else do I know?
48 white.
I have some white flowers. I have 49 white. What do I know about the pink?
There are some.
There are some. That becomes a question mark. That's what I'm solving for. Clothing store had 42 shirts. After selling some, there were 16 left. Okay, I know the total. First part is the sum. I don't know that. And there were 16 left. I need to, right, that was flowers. This is shirts. These were sold. These were left. I want to talk about this problem and the language difficulties there are with this. I'm using the word sum, spelled S-O-M-E, for that question mark. And then the word sum, S-U-M, is the answer to an addition problem. Sorry, it's English. It's what we do to confuse people. We don't, all languages do it. English might be particularly bad, but we have words that sound alike. They're called homophones. They're different words, they have different meanings, and these are the things we have to discuss. How many left? In the olden days, we would have said, oh, if the word left is used, it means it's subtraction. In this case, you can solve it by subtraction, but I listened to a little girl tutoring a young man on Thursday, and she said you got you had 32 marbles in your left pocket and 12 marbles in your right pocket. He went, it's subtraction. And I was just walking by. I said, why did you say that? And he said, because it said left. I said, yeah, but it was a completely different thing. We can't use words to immediately say that's what type problem it is, because we use them in too many different contexts. Now, they could use subtraction for this, or they could add up. So, if I'm a teacher and immediately say, oh, this is a subtraction problem, and you were sitting there saying, oh, I can solve this by adding up, I've just totally undercut your confidence in what you knew, because I said it was something different. I don't say it's a subtraction problem. I say it's a problem to be solved. You may solve it either, any way you'd like. 26 magazines on shelf A, 16 magazines on shelf B. How many more magazines? So I can have my 26 on the top and my 60 on the bottom. We're still finding the difference. And I'm not labeling well because I know how late we are. This was shelf A, B, and this is about magazines. The last one even has an asterisk. This would be a good, solid problem. We would have kids work on this together. 38 fewer girls attended summer camp than boys. 79 girls attended. How many boys? Well, I know something. I know there were 79 girls, and there's a lot of different ways of drawing this, but I'm going to go here. There were 79 girls. There were 38 fewer girls. So that means my boys has to be 38 bigger. Do I now have a representation of the girls and the boys? This was a tough one. I have a good picture. I'm showing you this because now this is a picture of the information I have. This is a visual representation. I don't know what the question is yet, but I can answer practically anything now. So the question is, how many boys attended the summer camp? Oh, okay, I can add those two together. The next question is, how many children attended the summer camp? I add all three together. But I've got that picture of the information right there. Now I can figure out what to do. This is modeling. It's making the question visible on the paper. And it should have enough labeling that I can come back with it tomorrow and kind of read it on my own. So let's say I come back to this one, I look at that model, and I can say, oh, there were 80 flowers, I had 49 white, and I don't know how many pink. I've got the information there and understanding what to do. Okay, that is it. Your last page. As I mentioned, your kids should know their addition and subtraction facts to 10 automatically, and they should be pushing towards 20. We're about halfway through the year. It's time to start playing games. This online math fact practice, sorry, you're going to have to type that all in. I don't have a way of electronically giving it to you, is a page that has about 5 games on it that they can play. They're the type games that when I go to open it to double check that it still works, 20 minutes later it's like, oh, I'm not supposed to be playing the games. They're those fun, silly, addictive games. That's perfect. You get an immediate answer to whether you're right or wrong, and it's just got this fun component, so I see the problems over and over again. So when I miss 3 plus 11 the first time, I see it again 3 or 4 or 5 problems later, and then I see it again, and that helps that rote memorization. This one here, this is Common Sense Media, is a website that you should all know. It reviews everything. It reviews books, it reviews movies, it reviews math sites. It will tell you if there are ads on the sites, because your kids are still young. There's a lot of reasons not to go to a site with ads on them, because they're just being bombarded. It also will tell you when your kids move into middle school and high school. Is it developmentally appropriate? How much do you want them to be exposed to sexual content? This site has it for everything. It's a nonprofit. They're not representing anybody. But when those new movies and those new games come out, again, not at 2nd grade so much, but in a year or 2, or your older kids, they'll start pushing to see what they can get away with. Great site. But it does work. You can also go for the math sites. Math Playground. If your kids are finding the math very easy and want to be challenged, these logic games are phenomenal. Bedtime Math and Math Before Bed. One of these, I get them mixed up. Really, they couldn't come up with a more unique name. They had to copy the other one. Math Before Bed is a fairly new site. It's just this idea that we read to our kids every night. Why wouldn't we do something mathematical with them every night? Some of them are just gorgeous pictures, and what do you see? They're just really cool websites. These are extension. These are like, let's do something fun, because math really should be something exciting. Math cats, I think they absolutely have every problem deals with cats. I'm not sure about it. But it's a fun, cartoony type site. Last thing I talk about all the time, Dreambox is a pay-for. You would have to buy it, and I think it's expensive. I think it's $12 to $15 a month. Rave reviews. It's not going to go hand in hand with what they're learning in class, but it's a developmentally, they're just going to start playing math. It's a game format. I think it goes up to at least 8th grade, but it's something that they could start and do. Lots of kids love it. It's really good for number sense. So especially if your child if this arithmetic is coming easy to them, this would be something they could do to be challenged. I laugh because I consider that a very expensive website. I also know that I could wash $15 in my jeans and completely forget about it. So it's expensive in the world of websites. It's not a lot of money, but you don't need to do it either. I think there are definitely special kids who would really enjoy it. Yes, and I thank you. I knew this was going to run long, but I just thought it was worthwhile doing it properly. If you need to go, please do. I'm here for another 20 minutes to take questions. So if you need to skedaddle, please do. So I have a question here and here.